Welcome back to Knowledge Hub. Today, humanity knows more about space than we ever did before. Not only do we have detailed pictures provided by NASA's Hubble telescope, but mankind is also almost ready to go and explore other planets. Aerospace companies are developing rockets of all shapes and sizes. Scottish Skylark L, SpaceX's Falcon, Blue Origin's New Shepard are only some examples the general public is aware of. On the other hand, space still has many riddles people will need to solve. What's more, despite its seeming accessibility, most people still have plenty of misconceptions about space. The notion of silent space is just one of them. Let's find out how truly silent space actually is. How silent is space, really? Anyone who listened in school will tell you that space is a vacuum and sound does not travel through vacuum. While the second part of this statement is definitely true, the first one raises some questions. After all, vacuum is something completely devoid of matter. It has nothing, literally nothing, not even particles. But how can this statement be true about space if there are planets, and stars, and dust clouds, and matter? Don't rush to blame your high school physics course, though. From what we know about space now, most of it is, indeed, vacuum. Space is too large a place to begin with. The distance between all celestial bodies is, presumably, nothing but vacuum. In other words, space is mostly vacuum but not quite. So, if space is not all vacuum, does it mean that sound can travel through it? Are explosions silent in space? Do all other sounds remain silent, too? Before we answer that, let's just define what sound is and how it travels in the first place. So far, our knowledge of space is based on light waves because they have more travel capacity in vacuum. Sound, just like light, travels in waves that have more mechanical nature than light ones. By mechanical, one should understand sound vibration that travels through particles. So, when you play the guitar and touch a string, this mechanical vibration travels through air particles and creates the sound our ears can actually perceive. This effect is very similar to the ripples pebbles can create on the water surface. The original string vibration causes a chain reaction, and the sound travels. Quite logically, like any other wave of energy, it loses its effect eventually. In other words, the longer it travels, the weaker it becomes. Space was believed to be silent because celestial bodies and any other smaller particles, like stars' dust, are located too far from each other to make sound wave travel possible. But, as we've already established, space is not a complete vacuum, which makes sound travel possible, at least in theory. For the most part, space is silent. But not quite. Here, a lot would seem to depend on the wave force, and data discovered by NASA in 2006 indicates that the universe might be screaming back at us. NASA's space roar phenomenon. Space is not silent. In 2006, NASA fixed a complex instrument to a huge balloon and sent it into space. This experiment aimed to look for any sound waves coming from distant stars, and the results were short of astounding, completely disrupting previous silent space records. NASA's tool picked up signals 6 times louder than they originally expected. However, analyzing this signal is still challenging as there are several theories that could potentially explain it. One of the theories behind NASA discovered space roar is synchrotron radiation. This type of emission appears in the background when several different sources emit charged particles into magnetic fields. Since the 1960s, scientists believed that combined radio emissions from distant galaxies could create this kind of radio uproar. However, this signal's strength is puzzling because it doesn't look like there could be 6 times more galaxies outside our Milky Way. For almost 14 years, astronomers are debating the source of this signal. Some believe it could be coming from our galaxy rather than several different ones. According to Jack Singel, an associate professor of physics at the University of Richmond, the possibility that this roar is coming from the Milky Way is not completely ruled out. However, such a scenario still remains unlikely because it would imply our galaxy does not function the same way as any other spiral galaxy we are aware of. Some scientists, like David Brown, try to explain the phenomenon by string theory. However, the possibility of multiple alternate universes that could potentially explain this sound remains but a theory at the moment. Whenever this sound is coming from, one thing is for sure. Silence in space is not as silent as we think. And it really looks like the knowledge we have about space barely scratches the surface, even despite our advances in aerospace tech. One day, hopefully, we will have more answers than questions. Thanks for watching.